calculating how many moles are present in each of these samples. So the first one. So whenever you're converting moles to mass or mass to moles, and we are converting mass to moles here, you always need to find the molar mass of the compound you are using. So using what we learned in the first examples, the molar mass of iron is
changes. Remember, so if it's in I equals to us. So let's just do oxy acids.
159.2. So in these calculations, we're also going to have to take into account the significant figures present. And so always know that your molar mass is always an exact number. So you treat it that there are like infinite number of zeros after that number. So there are infinite number of sig figs in this number. So your sig figs is always going to be based off your initial number. So when converting moles to mass and mass to moles, you can always use a proportion. So we know that 159.7 grams are in 1 mole of this compound. So we have 150 grams of this compound over X moles. Using simple proportion, using math you probably learned in 8th grade, you can solve this proportion. So just 150 times 1 divide by 159.7. And that comes out to this is 0.9393 mole. We have 4. So for our second example, we have 10.0 milligrams of nitrate. So we're going to convert this from mass to moles. So when converting from mass to moles, you always want your substance to be in grams. And so we know that 1,000 milligrams is equal to 1 gram. So we can convert this to grams by moving the decimal place 3 places to the left. So 1, 2, 3. So that's 0.010 grams of NO2. So the molar mass of NO2 is 46.01. And we found this number from using the molar mass values in the periodic table and what we learned from in example 1 and 2. So we use a proportion. So 46.01 grams per 1 mole is equal to 0.010 grams over X moles. We'll solve the proportion to find X. So 0.01 times 1 divided by 46.01, and you get 0.000217.